swapping sum and generating function of harmonic number. This is a problem from Romanian Mathematical Magazine, right? And I found this problem like really good and like good use of techniques, right? So for the demonstration of these techniques, I have brought this problem here in this channel and hope you guys would enjoy and learn something new, right? Okay, so over here we have this sum. Sum is in the world of m first and in the world of n, right? And adds n minus 1 to the power minus m and m minus 1. Okay, turns out if we had like the inner sum going up to infinity, that's actually much better. So that's why we try to swap the order of sum, right? So first of all, we try to sum it in n and then m because we actually want the sum going to infinity inside. I mean, in inner sum. So that's why what you can do is if we check the domain in which it's being summed, right? If this is n, this is m. So n goes from 2 to infinity, right? And m goes from sorry. Okay, you let me actually write the outer sum in the x-axis m and that's easier. Okay, first of all, m is going from 3 to infinity, right? And n is going from 2 to m minus 1, right? So when m is 3, it's going up to 2, right? Because when it's 3, m minus 1 is 2, right? And when it's 4, it's going up to 3, right? When it's 5, it's going up to uh 4, right? And from 2, right? So thing is, this is our domain of summation. Yeah, it's going from like 2 to 2, 2 to 3, 2 to 4, 2 to 5, 2 to 6, and so on, right? So this is basically our n is equals to m minus 1 line. Okay, now, okay, so with m first, we could write this as m going from 3 to infinity and n going from m minus 1 to infinity. Sorry. And going from 2 to m minus 1, right? Now, if we consider to write n first, then we can just say uh, n going from, okay, to denote this same area, what we can also do is we can just consider n going from 2 to infinity, right? Yeah, and then what we can do is from here we get m to be n plus 1, right? And m's, let me write it another ink because it seems like it's being messed up. Okay, so I can just let n go from 2 to infinity, and then m will go from n plus 1 to infinity, right? So that's what I'm trying to do. So basically n goes from 2 to infinity, and then m goes, because this is m equals to n plus 1 and n equals to m minus 1. Those are same equations applied, right? So m goes from n plus 1 to infinity. So in that case, again, we cover this red area, which is basically the same area, right? Okay, so that's what we're gonna do. So n goes from 2 to infinity, and m goes from n plus 1 to infinity. Is that right? Yeah, n goes from 2 to infinity, and this m goes from n plus 1 to infinity. Yeah, that seems to be correct. Yeah. Okay. Yeah, I think yeah, okay, that's correct. Okay. Now let's do this sum. Now this is s sub n minus 1 over 2 to the power m, and then n times m minus n, right? So now this, since the inner sum is in m, we can take the terms of n out, right? As n minus 1 by n, right? And now this is sum from m is equals to n plus 1 to infinity of half to the power m by m minus n. Now I guess you guys notice that there's this m minus n over here, right? Also, I can actually write this sum in terms of m minus n, right? M minus n is equals to 1 to infinity. So that's why what I'm going to do is I'm going to rename m minus n as variable k, right? And then again, yeah, so just like there was, like m was free variable, now k is free variable, so it doesn't really matter. So yeah, so now this becomes from n equals 2 to infinity. Now this goes from k equals to 1 to infinity, and now this becomes half of m is now k plus n by k, right? So now I have to take this half to the power n outside, half to the power n outside, and this becomes sum from k is equals to 1 to infinity of half to the power k by k. Now we know that sum from k equals to 1 to infinity of x to the power k by k is minus ln of 1 minus x, right? Yeah, so that's why this becomes sum from n equals to 2 to infinity as n minus 1 by n half to the power n. This is minus ln of 1 minus half, right? Okay, 1 minus half just becomes ln of half, and minus ln of half becomes ln of 2. Yeah. Okay, now ln of 2 goes outside. Now we have this sum from n equals to 2 to infinity as n minus 1 by n half of n. Before we proceed ahead, let me first tell you the generating function for the harmonic number, right? Okay. Um. So let me first tell you about this. This basically generating function is harmonic number with x to the power n. So let me tell you what this sum will be. So what you can do is you can introduce harmonic number as a sum, right? From k is equals to 1 to n of 1 over k x to the power n. Now again, you can swap the sum using the same the summing area thing, right? So let this be k, let this be n. Over here, k goes from 1 to, sorry, I mean, let's write the outer variable in x-axis, that's easier. Okay, n and then k. So here n goes from 1 to infinity, right? And k goes from 1 to n. So when 1, like it goes from 1 to 1, 2 to 2, 3 to 3. So basically this line, like k equals to n line. So this is how a k goes, right? So this is the basically domain of summation. If you want to write in different way, like one of the way was basically n going from 1 to infinity and k going from 1 to n, right? Another way could be k going from 1 to infinity and n going from k to infinity, right? So basically what I'm trying to say is this this k will go from 1 to infinity, right? But this n will just go from k to infinity. So and this area is covered. So that's a good idea, right? Again, and if we swap in that way, we'll be able to sum it. So sum from k equals to 1 to infinity, sum from n is equals to k to infinity, 1 by k x to the power n. So now if we sum it, and this 1 by k just comes out, and we can use the geometric formula. We will of course assume this modulus of x to be less than 1, right? Because otherwise this sum just diverges, right? So this becomes x to the power k a by 1 minus r, right? The sum is a by 1 minus r for infinite series. Now after this, I can actually take 1 by 1 minus x outside, and this becomes sum from k is equals to 1 to infinity of x to the power k by k. And this one is just minus ln of 1 minus x, and 1 minus x from the outside. So this is a standard sum, right? So now we have summed up the harmonic, uh, the generating function of harmonic number. I'll just write in a different way because this will be helpful. I mean, the different way is from n equals 2 because that's how it's in the problem, right? So I'll write from n equals to 2 to infinity of as n x to the power n, right? And then, okay, sorry. If I write from 2, I have to subtract 1 over here, right? Okay. And minus ln of 1 minus x by 1 minus x. Now, that's not really what we want. We want generating function with also n denominator. So what I'm going to do is, I'm going to integrate both sides from 0 to y, right? And that way, okay, if I integrate, I will have that n in denominator. We will have sum of n minus 1 harmonic number, and then x to the power n by n, right? And then this is from 0 to y. Similarly, over here, we will have, okay, of course, there should be dx, right? And then over here, if I just let u as ln 1 minus x, that this minus 1 by 1 minus x dx will be du. So that's u square by 2. So that's ln square 1 minus x by 2 from 0 to y. So now this becomes sum from n is equals to 2 to infinity of as n minus 1 y to the power n by n becomes ln square 1 minus y by 2. Okay, this is a pretty interesting formula. I think both of these are interesting formula. Sum of the harmonic number, generating function of harmonic number with ln denominator. This is pretty simple. Ln is common minus y by 2. Similarly, this is also pretty simple. So both of these are helpful formulas actually, and like a lot of powerful results can be derived from these two formulas. Okay, so now since we have that, now we know that this becomes just okay, this is the same thing, right? We just have y as half over here. So if we use this, this is ln square 1 minus y is half by uh 2, right? And this becomes ln 2 and ln square half. And then because there's a square, like minus 1 square is just 1, so that's just ln square 2 by 2. And this is ln cubed 2 by 2. And that's the answer. So we have the answer as ln cubed 2 by 2. That's the answer. So to just recap, we first swapped the sum using this summing area thing, and then we also introduce a new variable k as m minus 1. Like all of these are pretty standard techniques in summation, right? And then we use the log sum formula, and then again we use generating function of the harmonic number, and that's give us the answer. So there are a lot of like standard tools of summation used here, and I hope you guys get those ideas from this video and try to use it in your own problem solving. That should go, guys, and I look forward to seeing you in the upcoming videos too.